In the previous video, we trained our network on how to forward packets with static routes to specific networks. And it's great, we've got full connectivity. However, another type of static route that we want to be aware of is a host static route. It's a static route that points in the direction of a single 32-bit IP address. That's what we're going to discuss, plan, and verify in this nugget. And based on our previous static routes, our network-based static routes, each of these routers has full reachability to each of these four networks. So that's perfect. So in adding a static host route, I think it might be fun to actually add an additional IP address to the network somewhere, and then we can create a static host route that's specific just to that 32-bit address, not to a network. So to do that, we could create something called a Loopback Interface. Now, a Loopback Interface is a fantastic creation, and it's a logical interface, and you can create hundreds of them, and you can put them on any device. And if we decided, for example, to put a logical loopback interface, what we would do in R3 is we'd go to configuration mode, and we would say interface loop for short for loopback, and then a number. So 0, 1, 11,000, 5 million, whatever number you want to put in there. If we wanted to create loopback 0, we could. That's often commonly used. And then once we type in interface loopback 0 and press enter, boom! At that moment, that loopback interface exists. And then we can use the command IP address. I'll put IP add for short, and then the address that we want to give it. So if we want to give that loopback address the address of 3.3.3.3, and with a 32-bit mask, you're not going to have any room for hosts on the network. It's just that one individual IP address that's logically on this logical loopback interface. And so a 32-bit mask is perfect for that. The next challenge that we're going to solve with a static host route is that now that we have that IP address and R3 knows how to reach it, it's directly connected, no one else does. So if we wanted to train R2 on how to reach the 3333 host address with a static host route, what we could do is on R2, we go into configuration mode and type in IP space route. If that looks familiar, it's because it's the same command we use for network-based routes, but this time we're going to add 3333 as the destination that we're trying to reach, and then we're going to use a mask of 32 bits. And that, my friends, is the difference between a network-based static route that is pointing to a network and a host-based static route, which is pointing to a specific 32-bit IP address. And then we would go ahead and say, in this case, if this was R2, we'd say the next hop to get to 3333 is going to be right here, which is R300 interface, which has the IP address of 10.23.0.3. And that's it. So without further ado, let's go ahead and create the loopback interface on R3, and then we'll create the static host route on R2. So here in the virtual lab environment, I'm on DC NUG. That's the main computer. And I'm going to go ahead and supply the password using the tools over on the right-hand side, and then log in. And I encourage you to practice these labs at least once, maybe twice, to really get the hands-on practice with the CLI and the show commands and the verification. They'll be very, very valuable for you as you continue to grow and study and learn and work with Cisco systems. So here on DC NUG, we have our little image for the network topology. I'm going to bring that up so we can see it. Great. And let's bring up PuTTY as well by double-clicking it in the upper left-hand corner on DC NUG. And then if we click on the Servers tab over here on the left, you can open up the devices you want to look at just by clicking on the device and then going to R2, and we'll go back to and we'll also go to R3, just so I have them all open. And just to keep it kind of clean, I'm going to go to each one of those tabs, press enter a few times just to kind of clean up the screen for a nice fresh start as we work with these devices. So here on R3, if we do a show IP route, I just want to verify that we have the routes that we left it with in our previous nugget, and we do. Fantastic. So here on R3, let's create a loopback interface. So we'll go into configuration mode, and to create a brand new logical interface, a loopback interface, we're going to type in interface space loopback space and then the number of our choice. I'm going to start with 0. So interface loopback 0, poof, we now have this interface, and we can now assign it an IP address. Let's assign it the IP address of 3.3.3.3 with a 32-bit mask, and it is done. Now, if we do a show IP route and take a look at that, we have the static routes, and we also have this new directly connected network of 3333. Fantastic. Now, the only problem in our topology is that the only person who knows how to reach this IP address of 3333 is R3, because it's directly connected. If we go over to R2, and we said, what do you know about the 3 network? We do a show IP route. R2 is going to say, not a clue. I don't know. I don't know how to get there. So what we could do is we could add a static route, and more specifically in this case, for this video, a host static route that points to a specific 32-bit long address. And to do that, we'll go into configuration mode. And here we'll do IP route 3.3.3.3 with a 32-bit mask. Space, and then the next hop. And let's take a peek at who that next hop is going to be. So for R2 to get to there, it's going to be 10.23.0.3. So we're going to use that as the next hop as part of our static route. Fantastic. So here we'll put in 10.23.0.3, press enter, and then we'll exit out and type in show IP route. And there is our new static route right there. Now let's test it. We'll do a ping to 3.3.3.3, press enter, success, and the crowd goes mild. But before we get too excited, I have a question for you. And that question is this. If this user right here, we'll call him Bob, and Bob is sitting on the 10.1.0 network, and I just confirmed a moment ago that Bob has the correct default gateway of 10.1.0.1. In fact, in the virtual lab environment, we don't have to just guess, we'll just go check. So let's go back to the lab environment, and I'm going to click on the client PC, and I'm going to log in. And let's go to a command prompt. That's one quick way of looking. And let's do an IP config. And sure enough, 10.1.0.10 is its IP address, and its default gateway is 10.1.0.1. Fantastic. So my question is, if Bob tried to ping 3.3.3.3, would that ping be successful? Yes or no? Take a moment and think about that. Why would it be successful, or why would it not be successful? And while we're pondering that, let's test it. Let's go back to Bob's computer and let's try the ping. So here at Bob's computer, we'll do a ping to 3.3.3.3 and wah, wah, wah. Reply from 10.1.0.1. That's R1's address. Destination host unreachable. Effectively, that means that R1, when it got that packet, saw the destination address that included the 3. It said, I don't know what to do. And it, instead of forwarding packets for the customer, it sent a reply message back to Bob saying, sorry, destination host unreachable. Effectively, I don't have a route for it. And we can verify that. If we go back to DCNUG, where we're running our terminal emulator, and over on R1, if we do a show IP route, it doesn't have a route for 3 anything, and it doesn't have a default route. And as a result, it can't forward to that network, but we can fix it here too. So as we build full connectivity to that 3.3.3.3 address with static routes, let's add a static route here on R1 as well. So IP route to get to 3.3.3.3. The next hop is going to be, and I'm going to look at my topology to make sure I get it right. So from R1's perspective, the next hop is going to be our 2.0.0 interface, which is 10.12.0.2. And that's what we're going to put in as the next hop. So that's 10.12.0.2. And with that done, let's go back to our client and try the ping again. So back to our client in the virtual lab environment and hit the up arrow key. And we are good to go. So we verified connectivity and that it works, and that's because we have a route on R1 that knows how to forward packets in the direction of 3.3.3.3. And we have a route on R2 that knows how to forward packets in the direction of 3.3.3.3. And we also have R3 who owns the route and is directly connected, so R3 knows how to get there as well. And one last piece I'd like to add to this, if we had these routes in place and Bob pings that 3.3.3.3 and didn't get a response, you know what else could be wrong? It could be that somewhere in the network, one of these routers like R2 or R3 doesn't have a route back to Bob's network of 10.1.0. Because for a ping to be successful, it has to not only get there, but it also has to be routed back. So that's another thing to watch out for when troubleshooting IP connectivity, is make sure we have routes in both directions for the packets involved. So in this video, we've taken a look at a loopback interface, a specific 32-bit address we applied logically to a router, and then created a static host route on R2 and R1 that allowed those two devices to forward packets in the direction of 3.3.3.3. We also verified it worked with a ping from the client to that IP address. And guess what? I've organized these videos on static routes in a very specific order, saving for the near end the default route, which could have saved us a lot of configuration, but I wanted us to get the hands-on practice and also to see the cause and effect of adding host and network-based static routes. So I'll see you in the next video as we discuss, configure, and verify default static routes in a Cisco environment. So till then, I hope this has been informative for you, and I'd like to thank you for viewing.